So the last class we learned about for loop, right? Further learn about what loops we learn. Okay. Now whenever you want to talk about a loop, you need to ask this question: why do we use a loop? Why I am going to use a loop? Why I'm going to use a loop if you want to repeat a statement? When you want to repeat a statement, the next statement question comes in your mind. What is a statement needs to be repeated? And then how many times it needs to be repeated? Okay, it needs to be determined. Then only I should use what a loop here. Okay. Now let's take a simple problem and we will see how I'm going to apply a loop here. Okay. Why I applied a loop here also. Let's see, in this case, I want to find the factorial of a number. Okay. What is a factor number? If I want to find the 5 factorial, what is 5 factorial is 1 into 2 into 3 into 4 into 5. Now if I give this expression to you, how you will convert this into a value? First what you will do, you will say 1 into 2 is 2, correct? Then what you will do, you will multiply 2 into 3 is what? 6. Then you will say 6 into 4 is 24 and 24 into 5 is what? 120. What you are doing, so you are right now, whatever the previous result you generated, that you remembered, that result you multiply with the next number, that result is going to become your next number to be multiplied, correct? So let us say here in this case is, how do I remember in a program? You can remember a value only through a variable. Here I remember through a brain, but in a program I can remember through a variable. Let's say I'm going to write like this. So I'm going to say, let's say variable f. I'm going to say first time I'm going to say 1 into 2. That becomes 2. That 2 gets multiplied with 3. That means that is stored here in f. That 2 is multiplied with 3 and stored in. I stored back in my brain, right? Therefore I stored back. The 6 I stored back in my f again. Now my f is 6. That 6 I'm going to multiply with 4. That become 1, 2. That 24 I am going to multiply with 5. That becomes 120. That 120 I am going to print it. Print, right? Now I am going to make small modification. Can I say right now my f is 1 and can I say f here? Right? Same 1 into 2. I can also say one more step further. My f is 1. F into 1 can be stored in it. Just to generalize the whole thing. That means here first time is 1. 1 into 1 is 1. 1 into 2 is 2. That's it. Over. May not be necessary for you, but it is just to generalize it. I'm doing this. Here, what I could see 1, 2, 3, 4, 5, all of them. But now, if you look at this is called a successive multiplication where you multiply the previous value with a new number. It's called successive multiplication. Right? Now, look at this. If you want to do this procedure, what I can do, I can identify a loop here. What is a loop here? See, the same statement got repeated, but this is not repeated, this is not repeated. This is only once. Whatever you want to do once, don't put in the loop. Put it where? Outside. This is repeated. But what is changing every time this is changing? Therefore, now what I can do, simple thing is, look at this. This statement I'm going to convert f is equal to f into, every time this was changing, correct? Therefore, I'm going to say I, but I should get a value, right? The value for I in range of, now I need to go 1 to what? 5 right now. Therefore 1 to 6 because 6 is exclusive. My f is equal to 1 needs to be initialized outside. Successive multiplication. Whenever you want to successively multiply, initialize a variable to 1. Whenever you want to successively add, initialize a variable to what? 0. Now you print this. Print. So this statement needs to be repeated 5 times. If I want to find the factorial of n, take the n from the user input. Take the input from the user, insert n, put n plus 1. Why? Because if I put n is exclusive, right? Therefore I put and print it. So when if I put n is 5, 1 to 6 is going to run. When I is 1, 1 into 1 is 1. When I is 2, 1 into 2 is 2. When I is 3, 2 into 3 is 6. When I become 4, 6 into 4 is 24. When I became 5, 24 into 5 is what? 120. I'm going to come out. I'm going to print 120. Got it? Therefore, first identify what is a statement needs to be repeated and how many times. Okay? Let's write a program. So let's do right now. What we said was my initialize and my f to 1, right? What we did, initialize f to 1, correct? Then what we wrote? For I in range of 1 to what? 6 for 5 factorial, right? And then we wrote because I want to find the factorial of 5, right? What is the statement needs to be repeated? F is equal to f into I, correct? And print, yeah, run my program. Found only correct. Now look at this. If I want to find the factorial of n is equal to int input enter n plus 1, correct? Run the code. Put 5. This 120. If I enter 6, I should get what? 6. The 720. I hope you understood this, yeah? So now let's go to another problem and see first how we need to approach a problem, yeah? Okay. So now let's go to the next problem. Now I want to find the sum of first n numbers, sum of up to 5. For example, I want to find the sum of up to 5, okay? Now what I do if I have it, 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10, 10 plus 5 is what? 15. What to do? Same, I was adding. So I'm going to say S is equal to 1 plus 2, right? 1 plus 2 is 3. S is equal to, what I need to do what? 3 plus 3 is 6. S is equal to 6 plus 4 is 10. S is equal to 10 plus 5 is 15. And print S. S is equal to, can I say S is equal to 0? And I can say in this case S plus 1 is a successive addition initialized to 0. Yeah, you'll get 1, 2, 3. What I should do, same thing I need to do. What I should write what in this case for I in range of, what I should write what? 1 to what? N plus 1, where I say S is equal to S plus I. Add it. Successive addition. Got it? Yeah? Okay. Now let's see here in this case, I want to build another problem. The problem is this. See, I want to say here is I want to find the sum of 1 plus 1 by 2 square plus 1 by 3 square plus 4 square plus 1 by n square. Actually, what is there here? 1 by 1 square. Actually, it is there. What we saw before was, we saw 1 plus 2 plus 3 plus what? But here what happened is, here if you actually say 1 by 1 is there, 2 by 1 is there, 3 by 1 is there, n by 1 is there. But here what is happening? My denominator becomes a numerator and the numerator is being squared. That means what I need to do here, simple thing here. Here what is happening here in this case is, what is getting changing here? My numerator is constant, same 1 only, but my denominator is a variable, correct? But what is happening here in this case, I need to write square of it. What is square of it? You can put I raised to 2 or you can I into I, but don't write like this. Why you should not write like this? If you write S is equal to S plus 1 by I into I, if you write it, it is going to do 1 by I, that will be multiplied by I, because division and multiplication has the same priority. Will move from where? Left to right for you. Therefore, don't do this. Therefore, put what? A bracket here. Yeah. So let us see this, the code, how it works. So I need to find the summation. If you want to find the summation, what I should put? S is what? 0. Correct. And I need to write there in this case, I won't put F also. S is equal to S plus 1 upon I into I. And purposely I'm going to make a mistake and show you. I want to put this. I put here 5. I got the answer wrong. 5.0. Because it divides. Actually, it's supposed to be. I put in a bracket here. Now I'm going to run. I put 5. I thought what? 1. Yeah. Okay. Now let's see here in these cases. I want to solve another problem. What is the problem? I want to do like this. See, I want to find the summation of this. Sum of 1 upon 2 plus 1 upon 3 factorial plus 1 upon 4 factorial plus 1 upon n factorial. Same, my numerator is constant. My denominator is first time is 1 factorial, then 2 factorial. What is 2 factorial? 1 into 2. 1 factorial into 2 is 2 factorial. What is 3 factorial? 2 factorial into 3 is 3 factorial. What is 4 factorial? 3 factorial into 4 is 4 factorial. That means whatever the previous factorial I have, multiply with the next number and get a new factorial. I need to add it. Correct? So here there are 2 things are involved. One is the successive addition. Other one is successive multiplication. To add it, that I need to have another variable For multiply, I need to have another variable. Okay. Come, let's solve the problem. So successive addition and successive multiplication. Now what I need to do first time, what is my numerator is same 1. My denominator is changing. What is putting factorial? What is this factorial is? The factorial is whatever the previous factorial I have, multiply with the current number. Now two statements are there inside the loop. Remember, two statements are inside the loop. Code. I'm going to put here 6. Yeah. First find the factorial and make it as a denominator. Okay. Now let's go to the next one. Now I want to slightly change this. Okay. Now what I wanted. I want the summation of 1 minus 1 upon 2 factorial. Let's say 1 upon 3 factorial plus 1 upon 5 factorial minus 1 upon 7 factorial plus 1 upon 9 factorial and minus goes up to n terms. So if I give n as 5, I need to add 5 terms. 1, 2, 3, 4, 5. In the 5 terms, every alternate is what? Sign is changing. One time it becomes positive, other time it becomes what? A negative it becomes. Correct? Okay. So let us see here how to solve this problem. Now tell me, if I want to solve this problem, do I need to generate 2 factorial? What is 3 factorial we said? 2 factorial into 3. Do I need to generate 2 factorial? Yes. But do I need to add it? No. Correct. Now first what I'm going to do right now, I'm going to make everything is positive. Then I will make it one negative for you. Don't worry. So now to generate 5 factorial, I have to generate 4 factorial. For generate 4 factorial, I need to generate what? 3 factorial, right? 3 factorial into 4 become 4 factorial. 4 factorial into 5 is what? 5 factorial. Therefore, I need to generate the factorials, but I don't need to what? Add them. I don't need to what? Add them. Correct? Therefore, in this case, what change I'm going to make in my code? I am going to generate the factorial, but I am not going to add the even ones. Even I modulus 2 is not equal to 0, then. But here what is the challenge I'm going to face? Look at this. What is the challenge I'm going to face is, if my n is 5, I need to add 5 terms. That 5 terms are up to 9 factorial. Whereas if I put like this, the loop is going to run only up to 5. But I need up to 9 I need to run. Okay. Therefore, if n is 5, I need up to 9 right now. Therefore, simply I'm going to write here. Why 2 into n? Because 5 means 9. Because if I put 10, it will up to run. 9 only will run for you. Correct? If 6 means 12, 2 into 6 is what? 12. It will run up to what? 11 is more. But my challenge is, what is the challenge? When I is, the first time when I come here, when I is 1, 1 modulus 2 is not equal to 0, it is going to add it. Next time when I is 2, factorial of 2 is generated, but 2 is not getting added. 2 modulus 2 0 false. But when I became 3, 3 factorial is generated. But 3 modulus 2 is what? 1. It is going to come and add it. But I need to subtract it. Therefore, one time I need to add, other time I need to what? Subtract. So the simple logic for you is, if we say plus into plus is what? Plus 1. Plus into minus is minus. Minus into minus is what? Plus. Correct? Therefore, what I'm going to do here, I'm going to apply this simple logic. What is the logic here? My numerator is first time I need 1. Second time I need minus 1. Right? Numerator is initially, I'm going to put first time when I came, my numerator is 1 only. But next time when I come, my numerator I need to what? Minus 1. Right? Okay. See, now we saw the sign was alternating right now. So therefore, what we did, the numerator was first time is 1, second time minus 1. Second time when I come to add it, minus 1, right? Therefore, what I'm going to do, simple thing. Numerator is 1. Here I'm going to simply write here in this place. Numerator is equal to minus numerator. First time when I came, I was 1. 1 modulus 2 is 1. I came inside, I added. Then numerator become minus numerator. Numerator became minus 1. Then I became 2. 2 factorial. I did not add it. Why? Because condition is false. 2 modulus 2 is not 0 is false. I became 3. Yes, 3 factorial. 3 modulus 2 became 1. I came inside. My s was the previous 1. Numerator is minus 1 divided by 3 factorial added. Now I say numerator is equal to minus numerator. That means what? Minus of minus becomes what? Plus. Next time I get what? Plus 1. Yeah. I put right now. I put it 5. Yeah. Let's little more get into deeper on this problem. Okay. Let's more. Now I want to solve this problem. I don't know if you all know the sign of x is being derived like this. Okay. X minus x raised to 3 upon 3 factorial, x raised to 5 upon 5 factorial minus x raised to 7 upon 7 factorial plus x raised to 9 upon 9 factorial. You need to add maximum 10 terms. Maximum what? 10 terms. 10 terms only need. Now this is, this is x upon 1 factorial. Here 1 upon 1 factorial is there, x upon 1 factorial. The denominator remains the same. The sign remains the same. But what is changing? The numerator value is changing. Numerator is first time x, then x cube, then x raised to 5. What is x cube? X into x square. What is x raised to 5? X cube into x square. What is x raised to 7? X raised to 5 into x square. That means every time I need to multiply x raised to 2 from the previous numerator and get what this. What is the first time numerator is what? X. Correct? Oh, simple. The solution is simple. What I should do numerators, I need to have an x. That's number of iteration is fixed 10 times right now. Therefore I put 2 into 10. What is changing here in this place is my x and 1. Again, x can be anything. Enter the angle. Correct now? But the user will enter the angle in degrees. He's going to enter 60, 30. But in sine, what is x is the angle in radian. Therefore, what you do? Convert how do you convert x is equal to x into pi by 180. X is equal to x into pi by 180. 3.14156 by 180. So first time, what is my numerator? First time when I come, what is my numerator? Should be what? My x. In the place of 1, it should be what? X. Therefore, what I'm going to do? I'm going to initialize my numerator. Why did not do here? X does not have a value here. Now, what was happening here in this case is the numerator, first time when I come, numerator is x, 1 factorial, 1 modulus 2 is not equal to 0, s was 0, 0 plus numerator is x, x upon 1 factorial. Now I say numerator. Next time when I come, what is my numerator? Should be minus x cube. Okay. Minus x it became. With the previous, I need to multiply what? X into x. X cube minus x cube. Then go for the next iteration. 2 factorial, false, come again. 3 factorial, true, minus 3 factorial, minus x cube into what? 3 factorial. I added with s. And I'm going to repeat the same. Okay, f is equal to what? 1. Successive multiple. I put 60. Okay, sir, how do I know what I did right or wrong? Okay, so let's compare. Okay, equal to. Now let's compare, or you can print and see. I can also print. What I can do, I can import the math. Okay, math dot sine of. Their x is what? Angle in what? Radians. Let's see both. The angle is what? 60. Now I need to both the same values. Okay, if you want to equate it and see, this should give true. If I put s here, the answer should be what? True. I should get both values are same. Sine 60, same, true. Got it? Yeah. Put any other value. Let's see. Sine 45. What is sine 45 is? Okay, that means some small fraction is changing. Let's put it and see what is changing. 45. I got this 3. Oh, one fraction is here 3. That I have 2 here. This 3 here. Okay, that's okay. Yeah. Okay, so now let's convert the same thing into a cost problem. Okay, let's convert into a cost problem. The cos of x is being found like this. Cos of x is 1 minus x square upon 2 factorial, 4 upon 4 factorial, 6 upon 6 factorial, and it goes up to what? What's the difference here? Here I need to have add all the even ones, but here what has happened? It's going to be 0 factorial. Well, what 0 factorial is how much? It is what? 1, right? The first time when I come, what I can do in this case is I can directly initialize 1 upon 1. I can do it. 1 upon 1 is what? 1. The summation can be initialized to what? 1. But if we initialize to 1, what is the problem is here? My numerator, first time it starts with x square. The rest all is same. Correct now? First time is x square, second time x raised to 4. But all the even ones are added. But here I need to, there I added what? All the odd ones. Okay? Yeah, this is what I need to do. See, I'm going to start from here because cos 0 is also 1 only. Correct now? So you don't need to worry. So you can directly initialize a sum to what? 1. You can start initially numerators first time minus x square. Here my first time I need what? X. That's what I'm going to do. Simple thing. What was there? My numerator was initialized to what? Minus x square. Because first time I want to start with what? Minus x square. What is my sum is initialized to what? 1. Correct. Instead of adding all the odd ones, I need to add what? All the even ones. Cos. All the even ones got added. Remember that. Okay. Rest all is same. The difference was same. Sorry. I mod 2 into the angle. The angle is what? Let's say cos 60. Yeah, same. Run, enter, cos 45. Yeah, same. I got same. Yeah. Got it? Yeah. Any doubt, you can put it on the comments. I'm ready to help you all to solve this problem.